So in this problem, we're taking a random sample. We know it's normally distributed population producing the following data. So the mean, the estimation of the mean is going to be the sum of x over n. So we did that here. And we get 1.45. So if we were to have a normally distributed curve and we want a 95% confidence interval, then we're going to have to look at the t-table for the df to be n minus 1. N in this case is 11. So if I go to the distribution table with the df being 10, oops, in this case it's 10, so we get 2.228. For the tail to the right is 0.025. So we get 2.228. So we get 2.228. Then we use this formula to get the mean plus or minus t times the standard deviation of x bar. So standard deviation of x bar is calculated by taking the standard deviation divided by the square root of n. Standard deviation is calculated by taking the sum of x squared minus the sum of x quantity squared over n divided by the whole quantity n minus 1, and then take the square root of that. In this case, we get 2.1548. So plugging it in this formula to find the bounds, we get x bar, and in this case, be careful not to round. So we get 1.45, plus or minus the t, 2.228 times 2.1548. So this would give me a minus 3.35 to 6.26. And then the error for part C is going to be just t times s bar. So this part right here, again, is the error. So we're looking at some point around the mean, and we want to meet plus or minus this error for a confidence interval, or the margin of error. In this case, multiplying these numbers, we get 4.80. So it is the mean plus or minus 4.80. So hopefully that explains what's going on there. If you have any questions, please let me know.